Hello everyone, and welcome to our live coding session with Vert.x. And my name is Paulo Lopes, and this is Clement Escoffier, and Escoffier. Sorry, my bad. And we are two developers, core developers of the Vert.x team, and our session will be a live session. We're going to make some code. We're going to implement kind of a retro game. And in this retro game, you guys will see Vert.x. You're going to see a web application, a real-time web application, where you, in the end, will be able to interact with us on this game. So, because we only have like 30 minutes, we're going to start right away. And we're going to start from scratch. So, let's do this. So, I will start by creating a new project. And I'll say it's a Maven project. I'm going to give it a group ID, a group ID. Vertx. I'm going to call it Devoxx to be original, and version I'm going to call it 2015. I say next. I'm going to call it plumber game, for example. Yes. I say finish. So here we are. Hope it's readable for everyone, even in the back, and try to increase the font. So at the moment we have just a plain Maven project. In order to make it a Vert.x project, we'll need to include the Vert.x. So we have a dependency. I'm going to call it Vertx core. We're going to use the version 3.10, which is the latest stable version we have right now, and because May by default tries to use Java 1.5, we need to do some tweaking here. So I'm going to do here build plugins, and I'm going to cheat a bit. I'm going to copy this because that's one of those things that you don't.
So one thing about Vertx is that you need Java 1.8 because we heavily use lambda expression. You are going to see that, but also we have many API from Java 8 that we are using, so you really need a Java 8 JVM. What Paulo is doing here is also importing another plugin to create a fat jars. It's not required, but most of our users are using a Maven shade plugin to build a fat jar. So Vertx is completely unopinionated. You can use whatever tools you want. You don't have to use Maven. You can use Gradle, SBT, no build process at all. It's up to you. So here in this session we're using Maven, but you can imagine anything.
And since we are building a fat jar, we need to have an entry point for application. And I already hard-coded this class name. Of course, the class name, the class itself doesn't exist because we just created an empty project. So I'm going to go here and I'm going to do new Java class, give this name. And in Vert.x we have the concept of vertical. A vertical is like a small unit application. It's where everything starts. So you can bootstrap it yourself, but we have a helper class. Start vertical. And in this class, basically, you just need to override before it starts.
So what Vert.x is going to do is starting a launcher class that Vert.x provides, deploys this vertical. That's all. So, but you can do that in a main method or use this utility method. It's up to you. So here we're just.
So, yeah, we just create this. So I will try to show. Maybe we can install, blah, blah, blah. Does some stuff.
So the fat jar has been created. And to launch a fat jar, it's a fat jar and embed all the dependencies. You just do java-jar, the name of the jar. And, well, you see hello Vertx. But that's far from being a game.
Yeah. So, congratulations, you just been introduced to Vert.x. You just have the first experience with Vert.x. So, in order to speed up our development, what I'm going to do, because one of the things that we have to do a lot is stop and start and compile. And the one interesting feature that I would like to show you guys is that we can do stuff like the people from Node.js are used to, like a watcher that looks for file modifications, and every time there's a file for modification, we have a new build, a new redeployment, and you're done. So you don't need to be constantly stopping, compile, start. So what I'm going to do, I'm going to start a script. I call it run sh, just because. And basically, this script is quite simple. So what I'm doing is like invoking Maven package, and I will say then when my file is compiled, I will run it to make it a bit more readable. I will say that I want to redeploy every time any of these patterns on file names changes, and when it redeploys, I want it to rerun the script. So I just save this, and because I need to change the permissions to make it executable, so I should have, well, probably don't see it. Oh, it's green now, so it's executable. So if I do this,
so the first time you just do a Maven package and then launch a redeployment. So when you see that, it's when using in a redeploy mode, it starts the application in background and kills it, runs the process, restart it. So there is for sure no leaks and so on. So you can customize the redeploy pattern, customize the redeploy action. So if you're using a different build process like SBT or NPM, grunt, gulp, it works. You just say, okay, which command you want to use. So it's really unopinionated.
Since we are short on time, I've already prepared a bit of the JavaScript side. So what I just did, I copied a minimal game library that you can find on the internet. I copied a bunch of external JavaScript libraries that this game library requires, and I have a base simple style sheet. And to speed up this, what I'm going to do here, I'm going to wait for the add watcher to come up, and I will say every time I change the CoffeeScript files, recompile them for me. So, because that's what the browser is expecting from. So we created this, and we have now a way to serve. We have now files that we like to serve, but as you could see from the code itself, we don't have any web server yet implemented because our code is still an hello world. So in order to do that, I'm going to include the Vertx Web component. So to do that,
so it will just be a Maven dependency about Vertx Web, same version as a Vertx core. It's called Vertx Web, and it contains absolutely everything to do sophisticated web applications using Vertex. It's a bit like Express if you use Node, so you will declare your routes, and for every route you will declare a handler, and the handler will be responsible for serving the requests. So here, Toverlaw is creating a router, which will be our entry point, and on this router, it will just register a couple of routes and handlers, such as static handlers to serve static files, and we will see a couple of routes too, and so this one will probably be the static handler, so to serve all the JavaScripts and CSS and libs we have. By default, the static handler is looking in the web root directory, and that's why it's resources/web routes. All those resources will be packaged inside the file jars, but you can obviously use them, serve them from the file disk too, so from the file system. The last line, Paulo has created an HTTP server. In Vertex, it's just one line. You just say, okay, create an HTTP server. Who is going to handle the request? It will be the router, and I want to listen on the port 8080. That's all, one line. So obviously, we need an HTML page, and that's what Paulo is doing now.
I will use a template I have already pre-prepared again, because of the time. So basically, it's a simple HTML page with some title and empty canvas. So as soon as the file is saved, the application is redeployed. So I can quickly go here and I can do a new tab, localhost 80. Oh, sorry, you guys already seen too much. Cache.
No, I think it didn't redeploy.
Oh, wait.
starting. That's done. Okay.
It's still. Up. So if I now refresh, as you see, you have an empty canvas. So now we have the base for our game. So we're gonna start doing our game. So to do our game, we will have a game that works with two modes. We have a spectator mode, is what you guys can see behind me in the big screen.
Yeah. And you will have an active mode, a player mode that you can play on your phone or whatever. So it's really two different modes. So it will be hit games. So you have on the spectator mode, you will see yellow squares, which are leaks. And on your mobile phone or browser, you will have a black square, and you need to hit tap where the leaks are, and you will score every time you had a leak. So it's a massively multiplayer game because you can all of you play on the same instance. One spectator view for all of you.
So the game is, as Clement just explained, is quite simple, and the game library has a couple of helper classes. So in this game we have basically two classes: a player game, as he just explained it. It's going to be you guys, and a leak is what you guys need to find, because the whole concept is like, let's find memory leaks, and you're always blind. You never know what to look for. So what the player code is doing, like every time there's an update, so there's a tick function behind this. Every time there's an update, it needs to clear the screen if there were any drawn objects before, and if there's a collision with a leak, then we will show some new particle with some color red. Then you see, okay, I found it, and in the end cleared. And the leak is quite simple. It's just some yellow square that will slowly going down, and you guys need to catch it. So this is the code, and because we have our index HTML, it's quite simple. I'm going to now import all the JavaScript libraries that we had before, that I showed you guys before. So again, I will cheat a bit. I'm going to go here, and I'm going to up. So it's pretty much the same it was before, but now there's a bunch of scripts. And in the end, I have this Spectator.js, which is the compiled spectator. If everything is going all right, this thing should be like doing all the magic in the background, so I can just go here and of course, because it's demo, it will never work as you like. What's going on? Config is. Let me see. So spectator. The MGL. Oh, the MGL library isn't. Oh, yeah. So because I changed the file, but it didn't generate the JavaScript for it, so it should now. Yeah.
Yes.
There you go. We have our base game, so you see the memory leaks going on, and once we start the game, we now need to do the interactive part from with you guys.
So every yellow square is a leak, and your goal on the player side is you will have a black square, but you need to find where are the leaks. Obviously, as you will see the screen, it will be a bit easier, but you will see it's quite retro as a game, but it's quite fun too.
Mm-hmm. So, because I need to identify all you guys, I cannot use a plain HTML file. I'll use a template. For this example, I will create a JTemplate. So I'm gonna do templates. Game.
So again, Vertx is completely unopinionated. You can use any template engines. Right now, we support Jade, Simleaf. And a couple of other one too. It's pretty easy to add another template engine in Vertx.
So I just created this. I don't need to compile. And the dynamic part is that we will inject a player ID generated by the server. So in order to get Jade to work, of course,
you need the Jade template engine. So we provide it as a dependency. It's Vertx Web.
Vertx Web Jade. Yes, and now I have Vertex. So, and we should have now Jade support.
So now we need to say, hey, when we ask for this page, use the Jade template engine. So it's what Paulo is going to do here, instantiate a new Jade template engine using the create method, and hook some
code here. I'm going to do that when there's a HTTP GET request to game. I will handle your code with a template engine, so in order to not mess up this.
So what you have here is you declare a route. The get is a HTTP verb. And when you get a request on this one, you will call this handler. This handler here is implemented as a lambda expression. That's one of the reasons why we need Java 8, because we are using a lot of lambda expression. Inside, you just get a player ID and then serve the page using the JED template engine.
Mm-hmm. And another important thing is that up to now, there's no communication between the web browser and the server. So we're going to include here our sock.js bridge. So we will be able to connect between the two worlds.
So sock.js is a library that starts using WebSockets and will degrade smoothly till long polling. And the idea is that we can send events, and the clients can also, the browser can also communicate. In Vertex, we go a bit further. The idea of the sock.js bridge is that it's plugged to the Vertex event bus. So all events that Vertex is handling will be accessible from the browser, and the browser can also send events to any of the components that are plugged on the Vertex event bus. So is adding a route to say, okay, when you have a request on this event bus, on this route, so /event bus /star, then create the event bus bridge, and with this configuration. So in this configuration, we have to say which address from the event bus we accept in inbound and outbound. This is just to avoid to flood the browser, because imagine that you have a really large application with many events. Then the browser will get all of them, or your browser will get all of them. That would be terrible for the performance. So that's why we have this feature. So we just configure bridge options, and inside this we will add some permitted routes.
Mm-hmm. And by default, the bridge options are always the bridge is always closed, so nothing is allowed in and out. We will later come to this, but this is the server setup, and now we're going to do the client setup. So when the game starts, all we need to do is this. So we create a new event bus object, and when it opens, it will do something. At the moment, we don't do anything yet. So this is what we need, and we have the client mode. So I'll also create now the coffee, and I will go here.
So right now it's just developing the player part. It will be very simple. You just hit some places, send the places to the server, and the server decide if you hit the leaks or not.
So as we said before, by default, the bridge is always closed. So we're saying here when the event bus is open, we send a message. This message will never reach the server, so we need to allow this. And to do this, we just need to change the bridge options. So if I know...
So we just add the permitted routes and the permitted address and the inbound and outbound on the sock.js bridge in the Java side. So yes, as Paulo said, by default we don't accept anything, so you really need to do that. It's like a small security feature.
So at this moment, everything is we allow in and out, because all the requests need to be routed through the server application. And if we go to the browser, well, we have our game running here. I can create a new one. Localhost 80 game.
So that's what you will have on your mobile phone or on your browser. So that's the player side.
I'm just gonna try to make it this split screen. So we have now something, but there's no interaction yet. And that's because we haven't coded what happens when there's interaction. So on our spectator mode, we're gonna need to keep track of how many players we have, and some action will happen when we receive some messages. And we have two kinds of messages, like join and hit. Shoot, yeah. So if I go back to the spectator, as I said here, I will replace. So I have the list of players, and when we connect, we now listen to these two events. I wait for the deployment. I refresh. I can start this. So if I go here, you see a white dot. That's me already interacting with the game. So at this moment, we have a working, very simple game working. So we are almost done, because all these options are in, but it's not a real game if we don't save scores, because, well, a game, it's a competition, so you need to win. So in order to do this, we will define a new address saying that our web browsers are allowed to send us
so to another address. So let's call it score.
And now we need to do something with this address. So what we're going to do here is Vertx event.
So right now we were listening inside our server to all events that goes on this address, and every time we get we get an event, for simplicity we'll just display the ID of the user, but you can imagine serving a page or updating the score in the database or whatever you want.
So I'm gonna again a bit cheat, because otherwise I'll be mistyping a lot.
So what we get from inside the event, it's a JSON object. In Vertx, we are using a lot of JSON objects. So it's a message containing a JSON object, and we just display on the screen, on the console, what was contained in this JSON object.
Of course, now we need to receive these messages, and these messages, because it's a game, we can never trust the player. So we will send these messages from the spectator mode. So if I go back to the code here, as I show you guys in the beginning, there's this collision test. So if the player is colliding with a lick, we do some animation, and then
we will send the score to the event bus.
So I will.
So that really means that your browser is sending message to the server, but to all other browsers too. So you can imagine really scenarios where everything is communicating with everything using events.
So if I refresh, and if I refresh the player, if I now try to get some collisions, and you guys see, and if I switch back to IntelliJ, I get some it and the player ID. The player ID, it was just a counter. It's not saved, but for the sake of the demo, it's good enough. So, but it's not really a good game if there's no sound. So we
need a retro sound.
And we still have a few minutes, so let's make this a bit more fun. So what I will do, I will go to the here, and I can do, where's the winner begin? I will initialize my drum machine. I will set a bunch of random sounds, and I don't know if you guys will get sound from this HDMI connection. Otherwise, I need to get really close to my laptop. So, no, I need to get close to my.
You hear something? That's really retro, right? You cannot be more retro than this music.
So if you now do something, it's fun, but you expect some extra sounds when you do this hits. So I will stop this by switching to a different tab. And what I'm gonna do, I need to change a little bit the player class to also have the knowledge about sound. So when the class is created, I will create a sound engine, I will set a special sound, and here when we hit, what I'm gonna do, I'm gonna play that generated sound. So this is really old school in the sense that, yeah, it's, let me see, indentation, yes, it's fine. So if we look here, I think it's redeployed. So if I go back, let me first refresh. So yeah, the music going on here, this. Oh, I start like scoring right away. So if you guys.
Really retro again.
And if, let me see, config. If you guys probably, if you're lucky with the Wi-Fi, if you go to this, if you go to this IP address, I don't know if it's visible.
So just copy it in your browser. Here.
Yeah, copy. I can close it. If you go here, oh, what? So, what was that? If you go.
So in 172.17.223.173.
Very simple. On port 8080/game. You guys will be able to interact directly with the screen.
So if you take your phone, so that you're on the same network and you start using this, you can start playing.
And that's...
No, we don't have firewall, but
it's probably the Wi-Fi. So because we thought of that problem, we already deployed the game online, and well, we have it running on.
So exactly the same code.
Let me.
No, you need the barcode.
Yeah, wait. But I need to start Spectator Mode here, and I switch it to this side, and this is the barcode. For probably if you guys can. Yeah, it's not me.
So we have new players.
Yeah.
So in 30 minutes, in less than 30 minutes, we have developed a Vertx, or a game based on Vertx Web, on the SockJS. Okay, it's a retro game, but imagine what you can do in 1 hour or 2 hours.
Gee.
Yeah, so we have many users now.
Yeah.
That was not a good idea, the sound. Yeah, that's, that was the last feature we added. That was. So if you're interested by Vertx, we also have a talk on Thursday, really on Vertx, about its concept, about its non-blocking features, its asynchronous features, how you can deploy microservices applications, web application, games with Vertx. Vertx is asynchronous and polyglot, so here we did JavaScript and Java, but we can use JavaScript, Java, Groovy, Ruby. Soon we can support Ceylon. We have communities that have added support for Scala and Python, so it's in progress, and even Kotlin. So, well, if you have questions about Vertx or about the game, we have a bit of time, or we'll be at the Red Hat booth or on Thursday for the conference talk, which go much deeper in the details and really how it works and how explaining why we can do that in a couple of minutes, thanks to the few concepts that are used by Vertx. Vertx can be summarized in one slide, seriously. Any question? Yeah, the code will be shared on GitHub. We will probably tweet about that, so follow us. So either Jedron or Clement Plop on Twitter, and you will get the full code with the sounds too. So the sounds are random. So if you repackage it or restart it, it might be a bit different. But yeah, that's the idea. Another question? Okay, so thank you very much.
Thank you.